Hello everyone, welcome to my channel. First of all, I want to thanks everyone for the overwhelming response from my previous video. It actually motivates me a lot. I have got a few comments as well on creating more videos like this. Surely I will come up with a lot of videos in the different topics like AWS networking and security, monitoring, etc. So stay tuned to my channel. Okay, so let's begin today. So today I'm going to discuss about the AWS and networking components. Firstly, I will discuss on a virtual private clouds, VPC. The difference between VPC and the private cloud, it's a bit confusing. At least I got confused when I first started to learn AWS. So we'll discuss all about this. We'll discuss why we use VPC and then move on to learn about subnets and how they fit with VPC. Then we'll learn about the route tables and how they are used to direct the traffic to the different destinations, both internally to VPC and to the external world. Then we'll look into the different security features offered by AWS like a NACL and their security groups. We'll also look into Internet Gateway and NAT Gateway and what they're used for. And at the end, we'll look at the Bastion host and how they can be used. So we'll do the demo related to all these concepts that we'll be learning so that we can get a clearer understanding. As well as while doing the demo, I will explain to you about all these concepts like VPC, subnets, the security features like NACL, security groups, etc. So without further wasting our time, let's begin. Now coming to this architecture which I'm showing right at this moment, let us first understand this architecture. So we have a region US East. Here we are going to create a VPC and two private subnets like private subnet 1, private subnet 2 and two public subnet 1, public subnet 2 into a two different availability zones. Sorry, my bad. Here I have mentioned in the diagram the availability zone as the same, but we are going to create in a different availability zone. So now let us first understand what is the region, what is availability zone. So region are the separate geographical areas that AWS uses to house its infrastructure. So these are distributed among the world so that the customers can choose a region closest to them in order to host their cloud infrastructure. As in our case, it's a US East. Now we are going to create the VPC in this region. Now what is VPC? VPC is an isolated segment in the AWS public cloud which allows us to deploy our resources in a safe way. Now, when we create a VPC, the only person that has access is our own AWS account. By default, from the limitation perspective, actually, we are allowed up to 5 VPCs per region per AWS account. Now, what is the difference with the private cloud? Now, the private cloud is actually a physically isolated single tenant collection of the compute, network, and sometimes storage resources exclusively provisioned to just one organization or the application. Whereas virtual private cloud is nothing but it's defined as a multi-tenant but virtually isolated collection of a compute, network, and storage resources. A simple analogy comparing these two would be like choosing between a single private home. You can say the single private home as a private cloud versus an apartment building. You can take the apartment building as a VPC. Now, inside the regions, there are two availability zones, which are nothing but the data centers. Now, there are two public subnets. So, one public subnets here, another public subnets is here. So, and there are two private subnets. Now, what are these subnets? Subnet is actually a part of the network that we are going to create. Now, in other words, part of the entire availability zone, the one that we are mentioning over here. Now, each subnet must reside entirely within one availability zone and cannot span zones. So, to make these concepts more understandable, let us take an example of a office building. So, now office building has many floors, and since each floor has many individual cabins. The department like HR, payroll, etc., they sit either in one floor or in multiple floors. Let's think that AWS region is like the office building, and each floor of this building is like the availability zone. Like regions can have a multiple availability zone, so building also can have a multiple floors. Now each department is like the VPC. VPC spans across availability zone in region. Now similarly, each department can span across different floors. So I guess the concepts are getting clearer now. Now while we will be doing the demo, it will get you come to get a better understanding of all these concepts. Now, if we look at the diagram, we have the Internet Gateway, NAT Gateway, and the route table. Now, what is Internet Gateway? Internet Gateway actually allows instances with public IPs to access the internet. So it's basically a logical connection between the VPC and the intranet. Now, only one internet gateway can be associated to each VPC. Now, if a VPC does not have an internet gateway, then the resources in VPC cannot be accessed from the internet unless there is some other way, like the traffic flows via corporate network and VPN or direct connect. We'll come to all these concepts in my later videos. Now, Internet Gateway actually allows the resources within your public subnet to access the internet, and the internet to access the resources inside your public subnet. Now, a subnet is actually becomes a public subnet if it has a route table that directs traffic to the internet gateway. I'll show you while doing the demo how in the route table will just to direct the traffic to the internet gateway to make that uh, public subnet. Now, coming to NAT gateway. NAT gateway allows resources in a private subnet to access the internet. Now, why we need that? Say suppose I have a DB server in my private subnets, and there are some updates are needed, and we need to go to the internet to download those updates. So how I can do that? NAT gateway is the answer. So it only works in one way. The internet cannot get through your NAT to your private resources unless you explicitly allow it. Okay. Okay, now we have learned a lot of concepts in networking so far. So let us go to the AWS Management Console and try to create VPC, subnets, RouteTables, Internet Gateway, NAT gateways, so that all the concepts that we have learned so far gets clearer. Okay, so I am in the AWS Management Console. So let me go to the VPC, click on your VPC, and then click on create VPC. Let us give name my VPC. We need to specify the IPv4 CIDR block. So now how we will decide on this IP range? So let's say we are using 10.1 dot sorry uh, 10.1.0.0 slash 24. So whatever the numbers we specified after this front slash is called the subnet mask. So how many IP addresses are basically assigned by this CIDR group? So how will determine? It's a simple calculation. So let us go to this notepad. So it's nothing but 2 to the power 32 minus whatever the subnet mask that we have defined. So here we have defined 24. So 32 minus 24 is 8. So 2 to the power 8 is equal to 256 IP address. So here 256 IP addresses will be assigned by this CIDR block for VPC. Let's keep the rest of the things as a default and go down and click on create VPC. Okay, let us go to VPC. Okay, my VPC right now is in available state. Now we are going to create two subnets, one public subnet and another private subnet. So assume that we have an equal number of IP addresses for each subnet. So if we go to this notepad, each subnet will have 256 divided by 2 equal to 128 IP addresses. So it's equal to 2 to the power 7, which is equal to 2 to the power 32 minus 25. So we'll assign the CIDR block to public subnet as 10.1.0.0 slash 25. Its IP range is like 10.1.0.0 to 10.1.0 to 127. And for the private subnet, we'll assign the CIDR block to 10.1.0.120 slash 25, whose IP range would be 10.1.0.128 to 10.1.0.255. Now, why we have kept this as 128? So that the IP ranges does not overlap with the IP ranges of the public subnet. Okay. Now let's go back to the console and click on subnet. Let us click on create subnet. Select the VPC that we have created, my VPC. Okay. And give the subnet name my public subnet. Give the availability zone as US East 1A, and this CIDR block let us copy from here whatever we have calculated over here and paste it. Let us go and click on create subnet. So my public subnet got created. Now click on this my public subnet, click on actions and modify auto assign IP settings. Now why we need this? So over here you can see enable auto assign public IP4 address checkbox is not checked. So let us check this and click on save. Now why we need this? Now all the instances that will be launched inside this public subnet will have the public IPs assigned to them by default by AWS. So that's the main reason why we are doing this. Okay, now click on save. We're done with this. Now click on create subnet to create our private subnet. Okay, so select the VPC. Go ahead and give the subnet network like my private subnet. Okay, select the availability zone US East 1A. Okay, and then copy this IP address. Okay, and then click on create subnet. Okay, let me clear this filter. So my public subnet and my private subnet got created and both are in the available state. Okay, now we are done with creating of the two subnets. We are done creating a VPC. Now the next step is to create the internet gateway. So let us go to internet gateway, click on create internet gateway, give the name my internet gateway, and then click on create internet gateway. Okay, let's go back to internet gateway. So my internet gateway got created, but you can see the state over here stating as detached, so it is not attached to any VPC. So let us attach to the VPC. So click select my internet gateway, click on actions and attach to VPC. Come here and select the VPC that we have created and attach internet gateway. Okay, now let us create a public route table and configure it. So we'll create a route table and attach a public subnet to it, so that the instance launched within this subnet will have access to the internet. So let's go to route tables, click on create route tables. My public route table, give the name as my public route table. Select the VPC, my VPC. Okay, and come here and click on create route table. So a route table by the name my public RT got created. Now we need to attach the internet gateway. So for that what we will do, we'll select this my public RT, click on this route and click on edit routes. Here we'll click on add route. So any traffic coming from anywhere will route to my internet gateway, whichever we have created, and then we'll click save changes. So this route table now got a route to internet gateway. Now we need to associate this public subnet to the route table. So how we'll do that? Again we'll select this my public route table, click on subnet associations, and then over here you can see there is no subnet association explicitly mentioned over here. So what we'll do, we'll click on edit subnet association, we'll select our public subnet, and then we'll click on save associations. Okay, so now let us go to this public route table and see whether the subnet association is done properly or not. Yeah, now you can see my public subnet association is explicitly mentioned over here. Okay, now over here you can see there is one more route table got created, this one, and this is called the main route table. So this got created when we created our VPC. So we'll use this route table when we'll be creating the NAT gateway, but for the time being let us skip this. Okay, now the next step that we will be doing is to launch an EC2 instance inside the public subnet. Okay, so let us go to EC2, click on EC2, click on instances, click on launch instances, select Amazon Linux to AMI. So in my previous video I have explained how to launch an EC2 instance. So if you have not watched the video yet, please do watch it and come back over here so that you will have a better understanding. Now select this AMI. We'll choose the t2.micro, whichever is a free eligible one as an instance type. Then click on next, configure instance details. Here we'll select our VPC that we have created, my VPC, and we'll select the public subnet, and this auto assign public IP will make it as enable. Rest of the things will keep it as a default. Next, click on add storage. Let us keep it as a default. Then let us give a tag over here, public EC2 server. Then click on next, configure security group. Let us give a proper security group name, public security group. SSH is already mentioned over here, so we will not do anything else. Click on review and launch, and then click on launch. Once you click on launch, a pop-up window will come where will be asked to select an existing key pair or to create a new key pair. So in this scenario, we'll go ahead and create a new key pair. Let us give my key pair and download this key pair. Okay, okay. And I gave the name my key pair. My bad. Okay, now let me do one thing. Let me change it and download my key pair. Okay, and then you can click on launch instances. Okay, so let us go to view instances. So let us wait until it becomes running. Let us refresh. Yeah, now you can see it's in a running state. So what we'll do, we'll select this and we'll copy this public IP address and we'll keep it in a notepad. Okay, then let us create another instance, private instance inside the private subnet. So we'll do the same thing. uh, okay, we'll click on next, configure details. Here we'll choose the VPC and we'll choose the private subnet, and this one will make it as a disable. Then click on add storage. Let's do this. Click on add tag and then give the tag name as private EC2 server. Then click on next, configure security group. Give a proper name, private security group. SSH is mentioned over here. Go ahead and click on review and launch, and then click on launch. Here we can choose the my key pair that we have already downloaded while launching the public instance. So we'll use the same key pair and click on launch instances. Okay, let us go to view instances. Let us wait until my private EC2 server is also in a running state. In the meantime, what we'll do, we'll copy this IP address, private IP address, and I will put it in the notepad. Okay, let us refresh once more. Yeah, now both of my EC2 instance are in a running state. Okay, now let's SSH into public and the private EC2 instance and test the internet connectivity. So for that, first what we'll do, we'll open putty.gen.exe. We'll load the pm file, key pair file that we have downloaded while launching the instance. So my key pair, this is the one. Let us open it. Okay, then click on save private key, click on yes, and then with the same name, my key pair with .ppk extension, and save it into the same location. Okay, so once it is done, you can go ahead and close this key generator. Now open putty.exe. Okay. Now copy this IP, public IP that we have got while launching the public instance. So put it over here, and then click on SSH, click on auth, browse the ppk file that we have saved a few minutes by mykeypair.ppk, click on open, and then click on open. Let me accept it and then make it as a. Now let me log in with the username EC2 user. Okay, now we are inside our public EC2 instance. So let us switch to root user, sudo minus hyphen s. Okay, and then run the updates using the command yum hyphen y update. Now since the internet gateway is connected to the public subnet, so updates will be completed successfully over here. So let us wait until the updates gets completed. Okay, we are done. Now let us SSH into our private EC2 server from our public EC2 server. And in order to do that, we need to create the PM file in the public EC2 server, and we need to copy the details of the key pair. Keep This is the key pair we downloaded, right? So we need to copy this my key pair.pm from our local machine into the public EC2 server. So to do that, what we'll do, we'll type nano, and then what is the name we have given, my key pair, my key pair.pm. Okay, so then what we'll do, we'll go here, we'll click right click, edit, and we'll copy this entire thing. So and come here and paste it. Control X, yes, enter. Let us see whether the file is there. Yes, mykeepair.pm is there. Okay, now let us update the permissions for the keeper. Chmod 400 and mykeepair.pm. Okay, now using the private IP address we can do the SSH. So this is the command SSH hyphen I, and then mykeepair.pem, then ec2 hyphen user at the rate, and then we'll copy the IP address, Ctrl C, and paste it over here. Right, yes. Okay, now we are inside our private EC2 instance. So let us switch to the root user, sudo su, and then try to run the updates using the same command yum -y update. Now here, since no internet access is provided for the EC2 instances inside a private subnet, we'll not be able to get the updates, and after some time we'll get a failure message. So let us wait until we get the failure message. Okay, that's done now. Okay, so let me close this. Okay. So now what we'll do, we'll create a NAT gateway. Now this NAT gateway actually will help us to provide the internet access to the instances inside the private subnet. So let us close this for the time being. Okay, and let us go to here at management console and then type VPC, click on VPC, and then go to NAT gateways. Click on create NAT gateway. Let us give the name my NAT gateway. Select the public subnet. NAT gateway is always created inside a public subnet, so that is the reason why we are selecting the public subnet. And then click on this allocate elastic IP. So this elastic IP address will actually work as a public address and it will be visible to the outside. Okay, so now come here and click on create NAT gateway. Okay, let us go to NAT gateway. It's still in a pending state, so let us wait until the state becomes available. Let us refresh, and once it becomes available you can see the elastic IP address will also be populated over here. So let us wait. Let us refresh once more. Still in a pending state. Okay. It generally doesn't take that much time, but sometimes it takes this much of time. Let us wait for a few more minutes to get its state changed to available. Yeah, now you can see the state got changed to available and elastic IP address also got assigned. Okay, now we'll update the route table and configure the NAT gateway. So let us go to the route table. So this is the main route table that got created while creating the VPC. So we'll use this route table. So what we'll do to attach the NAT gateway, we'll select this, go to the route, edit, click on edit routes, click on add routes, and then this select the NAT gateway, select whatever the NAT gateway that we have created, and then click on save changes. Now the instances that is launched inside the private subnet can access the internet through the NAT gateway. So let's test the internet connection from the instance inside the private subnet. So let us SSH back into the public instance. So let me open the PuTTY once more. Okay, let us go to the public IP. Let us see, Control V, click this authentication, select the ppk file, click on open, give the username EC2 user. Okay, now switch to the root user, sudo and then SSH into the private server like SSH -I, then mykeepair.pem EC2 -user at, and then let us copy this private IP and paste it here. Okay, now switch to the root user. We are inside the private instance, so to the root user, and then try to run the updates yum -y update. Now you can see that the updates are getting loaded and the updates would be completed successfully. So what does it mean? This means that now my private EC2 server has the internet access. So let us wait until it gets completed. Okay, so we are done. Now let us close this terminal, click on OK. Okay, so we are done with our demo, but before proceeding further, let me explain to you guys the layer of security in a VPC, the security group and network access control list. Now what is security group? Security group is the firewall of EC2 instances. So it is basically the first layer of defense, and network ACL is the firewall of the VPC subnets. It is the second layer of defense. Okay. Now security groups are tied to an instance, whereas the network ACLs are tied to the subnet. Now network ACLs are applicable at the subnet level, so any instance inside the subnet with an associated NACL will follow the rules of NACL. Now the other difference between the security group and NACL is security groups are stateful. What does it mean? This means that any changes applied to an incoming rule will be automatically applied to the outgoing rule. For example, like if you allow an incoming port 80, then the outgoing port 80 will be automatically opened. Whereas in case of network ACLs, they are stateless. That means any changes applied to the incoming rule will not be applied to the outgoing rule. Like if you allow an incoming port 80, you would also need to apply the rule for outgoing traffic if you want to allow port 80. Okay. Another difference is that security groups support allow rules only. So by default, all rules are denied. So you cannot deny a certain IP address, but network ACLs support allow and deny rules. So by deny rules, we could explicitly deny a certain IP address. We can block, say, suppose IP address 123.201.57.39 from establishing a connection to my EC2 instance. Okay. Now subnet can have only one network ACL, whereas instance can have a multiple security group. Okay, so now we are going to discuss about the last topic of our video today. So that is the Bastion host. Now you have seen previously that we have created the VPC, we have created the subnets, NAT Gateway, Internet Gateways, and we have launched two instances, one instance inside the public subnet and one inside the private subnet. So these are the two instances. Now NAT Gateway allows the instance in the private network to go to the internet, but it does not allow anyone from the internet to access a resource in the private subnet. Now, if I need to do that, how we can do that? To achieve that, the only solution is Bastion host. Now, what is Bastion host? Now, Bastion host is a server whose purpose is to provide access to the private network from an external network, like internet. So, for example, here we can use the Bastion host to mitigate the risk of allowing SSH connections from an external network to the Linux instances that we have launched in the private subnet of our Amazon VPC. Okay. Now Bastion instance basically locates inside the public subnet, and we are going to connect our private instance through the Bastion host. Now in this example, we are going to use our public instance that we have created. So this public EC2 server as the Bastion instance. Now before creating the NAT gateway, I showed you like how we can copy the private key file into the public instance, and using that how we can SSH into the private instance. But in reality, please do not try to do that while creating the Bastion host. Thumb rule is never place your SSH private key on a Bastion host, as say suppose your Bastion host is compromised, then the hackers will have the access to your private instance. So instead, what we should do, we should use the SSH agent forwarding to connect to the Bastion host, and from there to the private instance. I will show you like how we can do that. So first let us go to the security group. Let me click on security group, and here you can see private SG and public SG. These are the two. uh, Let me refresh it. Okay. um, Let me see my private SG and my public SG. These are the two VPC security group that we have created. Okay, so let me go to my private is security group, and then go to the inbound rules, and then edit inbound rules. So here you can see for SSH we have 0.0.0.0/0. Delete this, and instead of that, we are going to use the security group of the public uh, instances. So where is my public security group? Here it is. And then what we'll do, we'll click on save rules. Okay, now what we need to do, we need to open pagent.exe. So this is basically, if you see over here, it's a putty authentication agent. So right click over here, we need to click on add key, and then select this, the ppk file that we have saved while launching the instances. So this is the ec2 keys.ppk, and we are done over here. Now let us open the putty. So let us open putty.exe. Okay, and then let us go to the instances. Click on select the public EC2 server, and click this public IPv4 address. Come to here, go to the data. You can give the username for the Linux instances EC2-user. Then go to SSH, click on authentication, and click this allow agent forwarding, and then click open, accept. So now we are inside the public instance. So we are basically inside the Bastion host. Now since we are logged into the Bastion host, now we can log into our private instance simply by typing this command like ssh ec2-user at the rate. Now we need to copy the, let us go to console, click on private ec2 server, and copy this private IPv4 address. Come back here in putty and paste that. Click on yes. Now see, we are inside our private instance. So if you want to see whether we are inside, just type ec2 in metadata, and see over here, no public IPv4 is available over here, and you will get the every information over here regarding this instance ID, instance type, what is its host name, and everything, and its local IPv4. See, this private IPv4 is 10.1.0.182 and web. Okay, So basically that's it, like how we can use the Bastion host to connect to our private instance from the external network. Now in the next video, in my upcoming video basically, I will be discussing about the connectivity to and from our VPCs using different methods, starting with how VPN and direct connectivity works. Then we'll explain how to connect two VPCs together to access resources in each VPC from each other using VPC peering. Then finally VPC Transit Gateway, which allows the multiple VPCs and remote data centers to connect to each other. So I hope this video helps you to understand the AWS networking concepts in depth. Please give your comments and don't forget to subscribe to my channel. So a lot of challenging and the interesting stuffs are going to come surely related to the AWS. So thank you for watching this video and I will see you in the next video.